In this section, we're dealing exclusively with first-order differential equations. That means differential equations that do not have any second derivatives, third derivatives, or higher. And so, in these situations, if we're able to isolate the derivative of the function dy dx and write that in terms of x and y, then we're able to draw what's called a direction field for this differential equation. The direction field is a visual tool which helps us to understand the shape of the solution without having to actually solve the equation. And the easiest way to see how this works is to just look at an example. Suppose we're considering the differential equation y prime equals y squared minus 1 with the initial condition that y of 0 is equal to 1/2. Well, we will be learning techniques to solve this differential equation in section 7.3, but for now, let's just look at its direction field. This is just a coordinate system decorated with a bunch of line segments at various locations throughout, and each line segment has the slope determined by the differential equation. Notice that all the points where y equals 0, the x-axis here, all of those line segments have slope equal to -1 because 0 squared minus 1 is -1, which means that y prime is -1 whenever y equals 0. And so at each of these points we just simply take the y coordinate and we plug it into this expression here to get the slope at that point. So for example, if y equals -1 or 1, then the slope is equal to 0, which we can see here, this horizontal line at 1 and at -1. And so now to see what a solution to this initial value problem will look like, we simply start at the point 0, 1/2, because the initial condition says that that point will lie on the curve, and we simply trace out a curve following the flow of traffic. And so I would get a curve that looks something like this. And so this is what I should expect a solution to this initial value problem to look like, even if I don't know an explicit equation for this curve. So let's take a look at the direction field for this differential equation. Again, I just go through, and at each of these points I just take the x-coordinate and the y-coordinate and I plug it into this expression here. So for example, on the y-axis, where x equals 0, all of these line segments have slope equal to 0, because if x equals 0, then this whole expression equals 0. Yes, it's a tedious process going through and writing all these little line segments and computing each of their slopes, but the end result is, as you can see, this nice visual tool. So let's try now to draw a solution curve through the point 0, 0. We just start at this point and we trace out the curve, again following the flow of traffic. And so this is what the curve will look like in this example. So to recap, the direction field is just a tool for qualitatively understanding solutions to a first-order differential equation. And the way that you draw the direction field is by drawing line segments at regular intervals with slope determined by the differential equation. In the next video, we're going to talk about actually solving differential equations explicitly. But for now, I'd like you to draw one direction field. I think this is probably the only direction field I will ever have you draw. But I do want you to try drawing this direction field so you can see what it looks like. And then I want you to sketch the solution to the initial value problem shown here. So give that a shot, and I will see you next time.